Charles law. Charles law states that for a given mass of gas at constant pressure, the volume is directly proportional to the absolute temperature. Mathematically, it can be stated as follows: V vs symbol T at constant temperature. V is equals to constant times T. V over T is now equals to a constant. If V1 is the volume of the given mass of gas at temperature T1 and V2 is the volume of the same mass of gas at temperature T2, then V1 over T1 is equals to V2 over T2 at constant pressure. The graphical representation of Charles law is as follows: volume against temperature graph. The graph will have an intercept at volume axis, that is y-axis, at the vertical axis. Then, since it will have an intercept, it will now have a contact at temperature at the negative coordinate of the temperature, which is 273 minus 273 degrees Celsius or 273 Kelvin absolute temperature. Volume of a gas is a function of Celsius temperature. The graph shows that at minus 273 degrees centigrade or Celsius, the gas has theoretically no volume. Minus 273 degrees Celsius is known as the absolute zero temperature. However, gas liquefies before this temperature is reached. Note that the graph is plotted using Celsius temperature. What will happen if Tk is plotted against volume? You see that we will have a very good straight line that will have an intercept at the origin, as we start from the origin in fact. Example 6. A fixed mass of gas of volume 546 cubic centimeter at 0 degrees Celsius is heated at constant pressure. What is the volume of the gas at 2 degrees Celsius? Solution. Since pressure is constant, we can use Charles law, that is V1 over T1 equals to V2 over T2. Where V1 is equals to 546 cm cube. T1 is the initial temperature, which is 0, because the temperature will rise from 0 to 2 degrees centigrade. Then we have T1 as 0 plus 273, which will give us 273 Kelvin. T2, which is equal to 2 degrees Celsius plus 273 Kelvin to convert to Kelvin temperature. We now have 275 Kelvin. Substituting the values, V2 is equal to V1 T2 all over T1, which will now give us 546 times 275 divided by 273 Kelvin, which will give us 550 cm cube. You note that T1 and T2 are converted to Kelvin. Absolute temperature is a standard used in solving these questions. Example 7. A fixed mass of gas occupies 40 cm cube at 0 degrees centigrade. Find the temperature at which its volume becomes 53.7 cm cube, assuming that its pressure remains constant. Since the pressure is constant, we can use Charles law, that is V1 over T1 equals to V2 over T2, where V1 is equals to 546 cm cube, T1 is equals to 0 plus 273, which will give us 273 Kelvin. T2 is equals to 202 plus 273 Kelvin, which will give us 275 Kelvin. Substituting the value, making V2 the subject of the formula, we have V1 T2 all over T1, which is equals to 546 times 275 divided by 273, which will give us 550 cm cube. Example 8. A fixed mass of gas occupies 40 cm cube at 0 degrees centigrade or Celsius. Find the temperature at which its volume becomes 54.7 cm cube, assuming that its pressure remains constant. Solution. Since pressure is constant, we can use Charle's law, that is V1 over T1 equals to V2 over T2. We have V1 is equals to 40 cm cube, T1 is 0 plus 273, which will give us 273 Kelvin. V2 is equals to 54.7 cm cube. Making T2 the subject of formula, by cross multiplying, T1 will go to V2, V1 will go to T2. Then making T2 the subject of the formula, T2 will now become V2 T times T1 all over V1. Substituting the values, we have that T2 is equal to 54.7 times 273 divided by 40, which will give us 373.3 Kelvin. Therefore, which was 373.3 minus 273 degrees centigrade will give us 100.3 degrees Celsius. The ideal gas equation. The relationship between pressure P, volume V, temperature T, and the number of moles N of any gas is expressed as pressure P times volume V equals to number of moles N times a constant R times temperature, absolute temperature T, or PV equals to nRT. The expression is called an equation of state, or the ideal gas equation. It states the product of pressure P and the volume V equals the number of moles N times a constant R times absolute temperature T. The equation holds true only if temperature is expressed in Kelvin. The numerical value of the constant R is 0.082 only if pressure is expressed in atmosphere, V in dm cube, N in moles, and temperature T in absolute temperature scale, Kelvin. Example 8. 4.0 mole of an ideal gas are at a temperature of minus 23 degrees Celsius and a pressure of 300 torr. What volume in dm cube will the gas occupy at temperature? Taking R equals to 0.082. Solution. Using the ideal gas equation, PV equal to nRT, where P equal to 300 torr, N equal to 4, R equal to 0.082, T equal to 273 plus minus 23, which will give you 250 Kelvin. We get on substituting 300 times V equal to 4 times 0.082 times 250. Making V the subject of the formula, we have that 4 times 0.082 times 250 divided by 300, which will now give us V 0, which is equals to 0.273 dm cube. Example 9. How many mole of a gas will occupy 4.0 cm cube at 1 atmospheric pressure and 0 degrees centigrade? A solution. Using the ideal gas equation, PV equals to nRT, where P is equals to 1 atmosphere, V equals to 4.0 dm cube, T equals to 0.0 plus 273 Kelvin, will give you 273